Hi, thank you for joining this session. I'm really happy to be your presenter today. This is Jake from MIDAS Geotech team. Speaking of the session, today's session is about underground safety assessment, particularly during deep excavation, as its name suggests. Especially, we are looking at how Korean geotechnical engineers evaluate safety before being under construction, with brief demonstration of seepage and seepage-stress FEM analysis. The reason why I can tell you this is that I was a geotech engineer for a few years in another company before. In there, I carried out a couple of projects, including safety assessment during excavation, ground improvement, and slope stabilities as well. By the way, this is just one concept of many to carry out the assessment, but simultaneously, this will give you guys some insights and awakening of the importance of assessment correctly as a geotechnical engineer. Let's go to the contents. Here are the contents we are talking about today. First one will be introduction. In here, I will tell you some of the reasons why this assessment emerged in South Korea as a special law. In the following sessions, I will let you know some things to be checked and analyzed in the reports. Second one is FEM analysis using GTS-NX. Specifically, I will perform transient seepage analysis and seepage stress coupled analysis for the ground safety assessment. Before we get to the point, over the world, as cities are bigger, the buildings are higher and deeper because of limited area. This situation affects a lot into the cities, specifically when excavation is carried out deeper and deeper. It could cause weakening of ground where we are standing. And several big incidents have attracted big attention of the public over the world. It's Japan, Texas, and Florida clockwise from the left. In particular, in South Korea, issues of potholes and sinkholes have increased year by year, reportedly by Ministry of Land, Infrastructure, and Transport, as you can see a chart on the right side. These images are the examples. To speak about the left picture, two pedestrians fell into a 3-meter depth hole all of a sudden and got hurt. And after the investigation, the fire agency found the hole was caused by the drain of the water by excavating the construction site located right next to the hole. Over here, this is a construction site, and hole was happened over here. Speaking of the right bottom side one, the news. A kindergarten building next to the site where excavation work was underway collapsed. It happened on weekend, so there were no people inside the building, hopefully. But if it is happened on weekdays, it would be terrible. People noticed that a series of these kind of cases, and the Korean government enacted a special law in 2018 called Ground Safety Assessment to prevent and predict risk factors during the excavation. So far, I have introduced the background of why this special law was enacted in South Korea. I know some of you guys feel bored with this explanation because it's not mandatory in your country, but it could give you some insights into how to apply it to your excavation project, and also you can see comparing it with your report form. So please focus on this for a few minutes. I will end up shortly. And then let's check which things have to be checked. The government suggested the manual publicly so that engineers can contain contents that have to be included inside, like this. I summarized with the big 6 main contents on the right side. Overview of the project, the investigation of adjacent sites, the investigation of the ground, transient CPG analysis, CPG stress coupled analysis, monitoring and measuring system. I will explain it in detail on the next pages. As I introduced now, the first chapter is an overview of the building project, including project location, blueprint, building size, excavation area and depth, construction period, and showing design drawings for the excavation. The second one is the investigation of the neighboring construction sites, buildings, and roads. And on this page, underground utility investigation is dealt with importantly. Specifically, sewage pipes and service water pipes are examined closely because if it becomes corroded as time goes by, it will be the critical reason for the sinkhole and pothole. So there are blue lines on the road and red lines with the purple and other underground utilities, including sewage pipes. The next contents are about the investigation of the ground, which is conducted inside the construction site, of course. It has information on strata, HEM value, water level, permeabilities for each soils, and so on. Based on this information, material values are determined and these values are utilized when we do FEM analysis. That's why these contents are located in third order. So you can see a drill log or other lab experiments for the strata's parameters. And when it comes to the fourth and fifth, we need to do FEM analysis to fill out all the blanks on the reports. First of all, we do transient seepage analysis considering water level from the boring hole information and with the rainfall intensity. As a result, we can get the designed water level to do conservative and reasonable analysis at the same time. This was about the fourth chapter. You can get some raising water level like this with the rainfall intensity. After that, with the designed water level from the seepage analysis, we do seepage-stress coupled analysis considering the construction sequence. And finally, we organize the results and write down the reports. To talk about the results in detail, we get designed water level from the seepage analysis and we do coupled analysis with this water level. The results such as subsidence of adjacent buildings and roads, maximum settlement of neighboring grounds, and vertical displacement with member forces from retaining wall will be noted. And additionally, the engineers calculate how much water flows following the retaining wall as well. In normal cases, there is no water quantity from the retaining wall, but we simulate the retaining wall as a porous one to add conservatism on FEM analysis. These results will be compared with theory and empirical formulas like PEC, club, and many. So finally, in sixth, the main contents are monitoring and measuring system divided by before, mid, after of the construction. Over here, a clinometer, water gauge, a strain gauge, crane measuring meter, and so on will be placed. Well, of course, all chapters are important, but in my opinion, this chapter is the second important thing in the whole chapter. Monitoring and measuring have to be dealt with importantly so much. Then let's move on to the next part of this presentation. The second part of this presentation is gonna be FEM analysis in GTS NX. As I already introduced to you guys, we will do two analysis cases. Transient seepage analysis considering rainfall intensity With this analysis, we will get designed water level for the coming analysis. And in CPG stress coupled analysis, we will get most of the results for the prediction and prevention from unexpected situations. Now, let's look at the GTS-NX. Before you go to the GTS-NX, in this case, I have a shoring design drawing originally, and to do FEM analysis, I just simplify the shoring design drawings like this. So water levels are here with the blue lines, and the soils are divided by the yellow lines, soil 1, 2, 3, and 4. And there are many lines for the king post and CIP, and the red lines meant that excavation level. But in the CPG analysis, we don't need to consider all of this. We have to consider the soil permeabilities and the surface flux on the surface of the ground. So I will import into GTS-NX these drawings. Click the file and imports. I just made the DXF. Click shoring design for seepage. You can see the depths are 44.8 meters and the 129. And first of all, I have to assign the properties, I mean the material for the ground, but I already put the all soils and properties as well. So I will just make a ground with the 2D mesh. Before we get to the start, we have to intersect all the edges. And erase some unnecessary lines. And make the outline faces. Imprint all the edges. And go to 2D generate and give the right mesh sets. This one is gonna be first soil, so I give the size 1. and soil 1. And also you can handle the higher order elements over here. Just apply. And grab all the stuff for the second ground. And I will give this soil 2. Repeat the work. Just give a right soil property. And that's all. That's all for CPG analysis. Hide all the edges because I don't need it. And after that, I will give the boundary conditions. There is no need constraint for the ground. I will just use the CPS consolidation analysis. Go to this tab, and I will use the nodal head function. The water levels are 41.82. And actually I just already brought a rainfall intensity from the government data. So as you can see, there is a time 0 to 30, and also they have each values millimeter per day. So I just changed into the meter per sec. So I just use this function, copy, and go to the generate function. You can just assign the surface flux. Then you can see time value, so just copy and paste. Then you can see the values are correctly input inside, and give the name rainfall and this value will be 1 because it's like a multiply with the function. So just give 1 meter and give the rainfall. And I'll choose the surface of the element. It means that I will give the rainfall on the surface. Click OK. And also don't forget giving the review boundary. So I will choose the surface of the ground. And click OK. Then go to the analysis case and stage set. But I'm just trying to show you how to use the unsaturated property function over here. Just click add in under the function tab. Then there is a database, or if you have any experiment for the soil, you can use that manually like this. But there is also database, so then you can easily assign the unsaturated function by clicking this one like this. In transient CPG analysis, you'd better use the unsaturated property function. And I'll add the construction set, go to CPG Analysis and add, then move all the meshes and initial water and save, and click add. Save, click new, and rainfall, and I will remove the initial water and go to the rainfall intensity with the review boundaries, and I will use the transient stage type, so then I can easily assign the time. Give me a second. I will change the parameter to day. So I will give this 30 days, and I will check the 30 steps as a result, and click OK. Then you can check all the results day by day. Click save, and just add the analysis case with the construction stage I just made. Seepage. You can handle the initial stresses with the casual condition or gravity condition, but in this case I don't need this function. Just click OK, then analysis it. Then I'll just skip it. Then you can see the results are like this. So in this case, I will check the water level with this multi-step ESO surface, and go to nodal seepage result and use the pour pressure head and give the 0 here. Then you can see the lines with the color. Then from the first stage, lastly, the waters are rising about 2.7 meter on the left side of the excavation part over here, and right side 2.27 meter are rising like this. And with this designed water level, I will move to the seepage-stress coupled analysis. Okay, this is the modified shoring design drawing with the designed water level from the seepage analysis. The water levels are located on the surface, following the surface, and other steps are same with the previous one in the CPG analysis. And go to GTS-NX and import the drawing. Then you can check the depth and the width, and I also input all the properties with the material in the GTS-NX to show briefly, and go to the intersect function and group all the edges. Click OK. It takes a little time, and make an outline face with the outline of the surface. Okay, and with the same way, I will use the imprint function. Go to the curve and click the face and group all the edges and click OK. Then The faces are divided by the edges, all the edges, like this. And I will start meshing. The first part will be first soil. So I just input the first soil with the size. With the 1 meter size over here, soil 1. And with the same way, I put the all soils with the faces. Second soil, give name, and grab all the faces. I will give the soil 3 over here, and lastly I will assign the soil 4 over the bottom, and erase all the edges, and I will extract just show the face over here, and I will extract the retaining wall with the extract element function here. I'll grab the edges for the retaining wall. I'm just using the face because I already imprinted on the face with the edges, and choose the CIP property and give the name. Then you can check the CIP elements has been made with this line. With the same way, I will make a strut, show face, and click the strut lines like this. The reason why I made at the same time, because I can modify the name with this message set function. So I will use the strut t9 strut, and over here you can you can add the new message sets and give the name strut second, strut third. This will be first, and choose the exclude elements in those, and grab the 1D and choose like this. Then you can see strut seconds are located in the right measure sets, and with the same way you can just assign the strut onto the right one. Then you can see all struts are located at the right measure sets, and skip this strut, and I will make a excavation part as well. Just add the new measure sets for the excavation part, and this one will be first excavation, second excavation, third excavation. With the same way, I will choose the first excavation part. It's gonna be like this. And just hide the first excavation part, and second one is gonna be like this. Third part is going to be here, so you can just choose the message set like this. GTS NX is pretty much powerful to use making meshes or making geometries in the application. So you don't need to be worried about when you have a trouble making meshes or geometries. So I will skip all the stuff for this, and this one I made already without boundary conditions. I will assign the boundary condition over here. First of all, I have to assign the constraint for the ground. Click constraints under the static slopes analysis and click auto and give the name ground. Then automatically the constraints are located following the outline. And also we have to put the self weights. The locations are automatically calculated with the GY. And then I'll assign the water level with the nodal head function. Just hide all the stuff without, and because in the shoring design drawing, the water are defined with the surface, so I just put the water level onto the surface. 45.6 water level, and this will be 44.8 44.82 water level. Click OK. Then the water level has been assigned correctly, and also I have to assign the limit boundary for the every excavation part. So I will hide the first excavation parts. Without H pile or post piles and stress as well. Go to the review boundary over here and click here to see the water flow and water quantity during the excavation. This one will be review boundary for first excavation parts, and with the same way I will erase the second excavation part and assign the review boundary with the same way. Second review boundary, and you can just follow the all steps repeatedly. And I will move to the stage set, I mean the construction stages, and click right button on your mouse and add construction set, and go to the stress seepage slope coupled analysis and click add. Then this will be stress and seepage analysis at the same time. I will make initial stages for the seepage. Add all the meshes for the ground. And you can see our meshes are located quickly for the initial stages, and go to ground constraints and water level over here and save. Secondary, click new, and this will be initial, but it's for the stress. So in this case I'll put the self weight change to the stress analysis stage type and move to the activate data with self-weight. Then you can see correctly assigned into the construction stages like this. First initial stage for the seepage, and second initial stress, and third will be null stage because it's not flat on the surface. To make that equilibrium, I will use the null stages and click clear displacement over here. And in this stage, this will be surcharge like a road or buildings near the construction site. So I forgot giving the pressure over here. Click plus and just define the places the loads are located and give the pressure like 13 load set. Click OK. Then the green arrows are over here. So I will input the road into the surcharge stages and click save. And this will be a retaining wall with the grouting. So I put the H pile, post pile, with the CIP, and just click save. And after that, I just prepared the all stage sets I already made. These are pretty easy to assign the stage sets like this: initial stages, null stages, surcharge, grouting with the CIP and H pile, retaining wall, excavation with the review boundaries, and strut, second excavation, strut, third strut. Repeatedly just follow the sequence, construction sequence. And I will add the analysis case. Click add, give name. And go to the analysis control. Over here, I choose the construction stages. Over here, you can choose which condition you want. Basically, the gravity condition is normal, but individually, I usually use the casual condition. So to use the casual condition, click initial stage for stress analysis and change to the first stress stage and click apply casual condition and click OK. And that's all. Just go to the running, serve the analysis case and click OK. It takes little time to be done, so I just prepared for the result parts. Here's the results. Over here you can see some results for the excavation. So first of all, I will check the displacement like this. You can see some maximum values and minimum values for the excavation sequence, and just choose the stages one you want to check. This is a first excavation and strut, second excavation strut. And importantly, I have to check the TY, it means the settlements for the neighboring soil. So if there are many buildings or roads on the nearing the construction sites, it causes some problems like collapse or just pothole and sinkhole inside the ground. So you have to check that. In GTS there is a probe function. With this function, you can see some results by clicking the node directly. So if you want to get some specific nodes, just click the nodes and the tags are popped up. So you easily can get the results like this. Or also there is an extract function, and to change to the displacement. And if there is a load for the, just grab the all nodes for the road with the static load function like this, and sort with the direction. It will be X, and get the table. Just click here, over here, and copy, and go to Excel sheet. Paste, and with these functions, you can get the table like this. I will show you this. You can get table directly from the GTS Annex. And I will check the H pile only to see the moment. Go to beam element forces, and you can check the shear forces, moment, and axial forces as well. And that's all for the reports. So you can get the table and results in GTS Annex correctly. So I will move to the presentation again. These are the result sample images. As I showed you, that left one is retaining wall vertical displacement, and right side one is road angular displacement. As you can see, there are stage sets, stage sequence with the maximum displacement of the vertical displacement from the retaining wall, the initial one, and following the sequence, the vertical displacement has emerged like this. And load angular displacements are here. You can check the allowable angular displacement with the remarks. And here's another result graph regarding water drawdown during the excavation. I forgot to show this type, so I will move to GTS Annex again. I will show you how to get the water drawdown. When you analyze all the steps and go to multi-step ISO, then over here you can check the pore pressure head and assign the 0. Then with the colorful line you can get the drawdown like this. From the bottom, there is a gap, 3.53 meter, uh, to the top to the bottom. From top to the bottom, it's like 3.94. So you can get the table like this. There is a sequence and all the drawdown each stages, and finally the results are it's okay. So finally, let's wrap it up for today. First, in South Korea, ground safety assessment is conducted as a special law because of many potholes and sinkhole has been emerged near the city. Second, the importance of checking is getting bigger and bigger worldwide because of the expansion of cities. And lastly, I just showed Korea's one to assess safety from the excavation work by conducting big two FEM analysis, seepage and seepage-stress component analysis, but find out the ways for your countries and do your job as geotech engineers. That's what we have to do. So we MIDAS geotech team will be supporters to you. And thank you so much for sharing, seeing this presentation. And if you guys have any questions, I will give you answers. If I couldn't give you answers in the presentation after the end of this presentation, maybe tomorrow will be sent the email to answer your questions, or give us email to geotech@midasIT.com below this page.